Okay, so in this problem, you're asked to calculate the molar volume of ethane, so that's unknown. And whenever they say molar volume, they ask you to calculate the molar volume. That means the problem is already implying that the number of moles is equal to 1. Okay, so you want to keep that in mind. And what's given to you is the pressure 1 atmosphere, temperature 0 degrees centigrade, and as soon as you see 0 degrees centigrade, you want to convert that into Kelvin, so that converts to 273.15 Kelvin. Okay, and the problem asks you to calculate the molar volume, and what they've given you is van der Waals equation, which I've written down in red out here. And if you look at this very carefully, you can actually apply the ideal gas equation to van der Waals equation. So let's take a look at that. So I'm going to write down the ideal gas equation in blue. So ideal gas equation is PV is equal to nRT. So from here, what you can do is, see, if you want to calculate the molar volume V, you see there's a V square out here in van der Waals, and that will complicate calculations. So what we want to do is, we want to demystify the van der Waals equation to simplify our calculations. And this term is typically a pretty small term. Okay, let me show you which term I'm talking about. This one out here, it's pretty small. So what we want to do is, it's not going to affect our calculations as much. Okay, so we're going to substitute the value of V from the ideal gas equation out here and put it into this. So let's write what we get from there. V is equal to nRT divided by P. So substituting into van der Waals equation, we're going to end up with P plus n square A divided by n square R square T square by P square times V minus NB. Okay, now keep in mind, we didn't really substitute this V out here, this one, because if we substitute that, then we really can't calculate the molar volume. Okay, so you want to keep that in mind. So now if you look at this carefully, you can cancel out n square and n square from here, which would give you P plus A divided by, A P square divided by R square T square times B minus NB is equal to nRT. Okay, so now is the time for us to start substituting the values. So if you look at the problem on top, pressure is 1 atmosphere, temperature is 273.15, A is 5.57, and B is 0.0649. So I'm going to put pressure 1.0 atmosphere plus A is 5.570. What I'm going to do is, I'm going to just remove all these atmospheres and moles just to make the picture look simpler. Okay, so that the calculation doesn't look, we can save some time. So pressure is 100 square divided by R is of course 0.821 square, and T is 273.15 square. Put this in parentheses, and then V is what we don't know, what we have to find out. N is 1, B is 0.06499. Put this in parentheses. That is equal to, N again is 1, R is 0.0821, and T is 273.15. Okay, so if you calculate this, if you demystify this expression out here, you will end up with a value which is 1.011076, and you're going to leave the V as it is, 0.06499, and the right side of the equation becomes 22.426. Okay, and if you solve for V, now it becomes pretty simple. V turns out to be 22.2 liters. Okay, so that's the equation solved with respect to that's the molar volume, solved with the help of van der Waals equation. Okay, now if you have to find out the volume with the help of the ideal gas equation, then you want to use this expression out here. So you can simply plug and play. I'm going to use a different color for that. Okay, so volume is equal to 1 times 0.0821 times 273.15 divided by pressure is 1. And if you see, this expression out here is exactly the same as this expression here. So therefore we can totally use that value out there. So we're going to write down 22.426 divided by 1, which is really 22.426. Okay, and that is the molar volume. You want to put liters out there. Molar volume using the ideal gas equation. Now this problem further goes on to ask you, what's the molar volume going to be if the pressure had to be, let me see if I can put this in a different color. If the pressure had to be 10.00 atmospheres. So if you look at the strategy is exactly the same. All you need to do is you need to instead of pressure out here and here, you need to plug in 10. So in this equation, instead of 1, you're going to have 10. Okay, so I'll put a 10 and then a 10, and as you can see, that gets squared and that remains as a 10. Moral of the story is, if you crunch the numbers correct, you should end up with 11.1076 times V minus 0.06499, which is equal to, as usual, the right side stays the same, 22.426. Okay, and from this you can actually get the value of V to be 2.02 liters. And if you want to, again, just like before, if you want to use the ideal gas equation to solve this, then V is equal to nRT by P, and we know nRT is that value out there. So we're going to get 22.426 divided by the new pressure is 10 atmospheres, which should be 2.24 liters. And that's how you solve this problem.